Welcome everyone to the microfab space of IBEC. This is a core infrastructure of IBEC, and is where our researchers, but also external ones and companies, come to fabricate biomedical devices of all kinds. A Cleanroom is a space where we care about the environmental conditions and the cleanliness. Environmental conditions as temperature, humidity, and pressure. Our Cleanroom is a 10,000 class, which means that we have 10,000 particles per cubic meter. This fulfills the conditions of a standard Cleanroom, but also allows entering biocompatible materials that usually are not allowed in high purity or in higher purity rooms. The other conditions as temperature, humidity, and pressure are constantly monitored to assure this uniformity of conditions during the fabrication of our researchers. For instance, the temperature is always kept in a range between 20 and 22 Celsius degrees, and the relative humidity is always kept between 45 and 55%. There is also a slight overpressure that drives all the contaminants to the exit and keeps renewing the air inside the room. Now, let's see how is our Cleanroom. And before that, we should dress in this way, with these lab suits and these covering accessories to keep this cleanliness inside the room. Let's go inside. This is our general room, where we have most of our characterization equipments. And also, we have the 3D setup, 3D printing setup. This setup is a DLP, which stands for Digital Light Processing. In this technique, we load digital design on this, and it's projected on a layer of resist that gets cured, and layer by layer is creating our 3D structure. This is an example of a structure fabricated by this technique. Yeah. And these pieces can be characterized, for instance, on this machine. This is an optical microscope to characterize in size this type of microstructures. This is a contact angle setup to measure surface interaction between different substrates. This, for example, is a measurement of hydrophobicity, very important in our biomedical world. And in this area, we have a profilometer. This is a light profilometer, optical, and this is mechanical. In the light one, we use the interference created by the light that is incident on our substrate and the reflected one. That creates an interference that depends on the topography that we have on our substrate. And this one is mechanical and works by using this small needle that maybe you can see there, that scans our surface like this and gets the profile of our structure. Like this, we can characterize our substrates in step height, but also in lateral dimensions, like in this case. Let's go to the next room. In this room, we also have several equipment. This one is a thin film deposition machine. Inside, we have several mechanisms to deposit materials, evaporators, and also sputtering sources. And what we can deposit by this machine are metals and semiconductors to create, for instance, electrodes. We have side equipment like an oven, hot plates, balances. This is a stethoscope. And we have another important instrument for us, which is this plasma generator. In particular, this one works with oxygen, and the oxygen plasma is very useful, for instance, to eliminate organic contaminants from our substrates, but also to activate the substrates for further processes that are done here in our space. Let's continue. Now we will enter the lithography area, which is the cleanest one and one of the most used. So in the lithography area, as you can see, we are working with yellow light. This is because the materials that are employed here are sensitive to the wavelengths of the white light, so they can be affected by the white light. And when we are working, we need to use this type. This room is divided in 3 spaces, and we will see each of them. Let's go to the first one. In this space, we have an optical microscope to characterize the fabrication done. And we also have this other equipment. It's a direct laser writer. And it's a lithography machine that has a source of light, which is a laser, so monochromatic. With this machine, we fabricate the masks for other processes of lithography, the ones that need a mask. Yeah? This is the type of things that we can fabricate, and this will serve us to transfer this pattern to a final device. So with this machine, we fabricate these chromium masks. Let's see how we continue in the next room. In this other room, we have some accessory equipment like hot plates or spin coaters. The spin coaters are used to deposit thin and uniform layers of photoresist. And once we have deposited a uniform layer of photoresist on one substrate like this is a silicon wafer, we take this substrate and the mask, and we use them together in this or these machines. These are mask aligners, and in this case, this is a mercury lamp that shines on this mask and transfers the pattern to one of these wafers. And this one, instead of a lamp, it's a LED, a diode, which shines with a single wafer. But also the result is the same. Transfer the pattern of the mask to the final substrate. And here you can see how we have the same pattern as before, transferred on a substrate. Let's go to the last part of the room. These are the chemical baths, and here is where we develop the lithography that we did in the other 2 rooms. So once we finish in the mask aligner with this substrate, we introduce it in a certain solvents and develop the final design. Here we do these development processes, the cleaning of the substrates, etchings, and this bench is prepared to handle all these materials. Something very important in our room is the management of the residues, and as you can see here, everything that is used in this room goes to a specific waste container. So nothing goes to the normal or regular trash, and everything has a process of recycling. It's very important for the environment. Finally, once we have this master, we can replicate this structure, and at the end get chips like this. This is a microfluidic chip replicated from one of those masters, having at the end the type of things that are done here at the clinic. That was all what we have. Thank you very much for your attention.